Hi guys, today we're going to learn about the average value of a continuous function. So, the mean value theorem for integrals says if f is continuous on a closed interval ab, then there exists a number c in the closed interval ab such that the integral from a to b f of x dx is equal to f of c times b minus a. The geometric interpretation of the mean value theorem for integrals is that for a positive function, let's call it f, there is a number c between a and b such that the rectangle with base from a to b and height f of c, that it's an output, has the same area as the region under the graph of f from a to b. In other words, c is the value of x on this interval ab, where you can build a perfect rectangle whose area is exactly equal to the area of the region under the graph of f from a to b. Something that could be like that, okay? It's not going to be perfect, but could be like this is, let's say that you have a curve, right? Something like this. This is your function, let's call it f. This is x, this is y, right? This is a, and this is b, okay? So the area of interest here, let's say that it's from here to here, okay? And let's say that c is here, okay? C is here. Therefore, your f of c is something like that, f of c. It's that height. Do you agree with that? Something like that. So what this theorem tells you is that this area, okay, that it's underneath that situation, okay, it's going to be exactly the same as this perfect rectangle that we have over here. Okay, so you copy it here. This is your a, this is your b, and what this theorem tells you is that this is the perfect rectangle, okay, that the theorem is talking about. The height is f of c, this, because it's the same height as this one, okay? Again, you have that this is y and this is x as usual, okay? So f of c is the height of this perfect rectangle, and b minus a, okay, because it's the distance from a to b, which you know that it's big minus small, is the base of the perfect rectangle. So the area of the perfect rectangle, what's going to be that? It's the integral, okay, from a to b, and then it would be what? F of x dx, right? The area of the perfect rectangle, it would be what? Well, the area of the perfect rectangle, this beautiful thing, is going to be f of c times b minus a, because it's base times height, okay? So the value of c is called the average value of the function f, and it's defined, we can call it f average, this little ab, okay? And it's going to be equal to 1 over b minus a, okay? Integral from a to b f of x dx. Why? What are we doing to this one? Technically speaking, what you are doing is you are dividing the b minus a to the other side. That's why you have it here as a denominator, okay? We're not doing anything crazy here, okay? So that's what you have. Cool. So this is the formula for the average value of the function f, and it comes from the mean value theorem for integrals, okay? You already know the mean value theorem for derivatives. This one is for integrals, okay? So how can we use this beautiful situation over here? Well, let's say that we have f of x is equal to 1 plus x squared, and the given interval -1 to 2. They ask you to find the average value of f on the given interval, excuse me. Well, yeah, we need to find integrals as well, okay? So what are we going to do? What you know is that f average, okay, is going to be equal to 1, okay? And what's going to be that? You know that b is going to be 2, okay, and minus 1 is going to be a, so minus minus is plus 1, okay? So I don't know why I put parentheses, but there you go, you have parentheses. Then it's the integral from -1 to 2, okay, because those are the numbers that we care about in this situation, okay, of the interval, and then of your function 1 plus x squared dx. Do you agree with that? So what are we going to do now? You integrate, okay? Well, you have that this operation is 1/3, don't forget about that one. Okay, then what happens? The integral of 1 is x, the integral of x squared is x cubed divided by 3, okay, evaluated from -1 to 2. Do you agree with that? After that, what do you have here? You have 1/3, okay? Then when you plug the 2, what's going to be that? It's going to be 2 plus, okay, you have that it's going to be 8/3, okay, so I'm going to put it here, 2 plus 8/3, okay, minus, okay, then you have that it's going to be what? -1, okay, minus 1 over 3. Do you agree with that? So that will give you the beautiful value 2. Okay, do you see it? Very nice. Okay, so you have that. Cool. Please do not forget the 1/3. It's very important. Okay, so then find C such that f average is equal to f of C. So what are we going to do? You already know that f average, okay, is this, right? That's your f average. So we want to know what f of C is. When you have f of C, you are going to use your original expression. That's your f of C. And then what are we going to do here? You are going to solve for x. Please use x. Do not use C, because we are trying to prove the existence of C. Okay, so leave it as x. Once we finish it and it's inside the interval, then that's another story. Cool. Okay, so you solve it for x. What happens? You pass the 1 to the other side, having x squared is equal to 1. Then you have that x is going to be equal to plus minus 1. Do you agree with that? So you have two possible C's. Ask yourself, is negative 1 inside the interval? Yes. Is positive 1 inside the interval? Yes. Therefore, what's your conclusion here? Thus, C is going to be equal to both negative 1 and 1 in this case. Yes, but the extreme it is, okay, so include it. Now, let's get to a graph of f and a rectangle whose area is the same as the area under the graph of f. Okay, so this one is a beautiful parabola. Okay, it's shifted up 1 unit, so you know that the vertex is here. Okay, in addition to that, when you plug 1, you know that this is going to be 2, so you know that you have a parabola here. Okay, with that, I'm going to have enough to kind of like guesstimate here my beautiful parabola, right? So you have something like this, right? That's your parabola. Sorry about that. Let me just put it here so you can see it. So what's the area of interest here? Well, they tell you that it's from negative 1 to 2, 1, 2. Okay, so the area that we care, it's something from here to something like that, right? So the area that we want is that one. But what's the height that we're using here? Okay, so the height that we're using is the height of 2. Okay, let me use another color so you can see that it's different. Okay, the height of this one is going to be 2. Okay, so this perfect rectangle that we're talking about is this one. So it seems that this, okay, like blue rectangle that we have over here is the same as this extra and then this extra. So do you see it? Very interesting. So this is your f. Okay, so you can see that it's very, very interesting. So what this theorem is telling you is this extra stuff that we have, it's going to replace this extra pseudo triangular situation that we have here. Isn't that beautiful? So you can see what's the visual of this beautiful theorem. Okay, so let's do more examples on the next page. So for this example, we have the table below gives values of a continuous function f. Use a left Riemann sum. Okay, they are already recalling all stuff. Left Riemann sum with 3 subintervals and values from the table. Okay, so from the table to estimate the average value. I mean, it's not going to be exact, so you're going to do an estimation of f on the interval 5, 17. So what are we going to do? Okay, what we know is that your f average, okay, f average is going to be roughly what? 1 over b minus a, so 17 minus 5, integral from what? 5 to 17, okay, of f of x dx, right? Do you agree with that? So you know that that's actually not an approximation, that's equal, right? The approximation is going to be as follows. You know that it's 1 over 12, right? Because that's 1 over 17 minus 5. And then you're going to do your Riemann sum, right? Instead of the integral from 5 to 17, you're going to put your Riemann sum. What's the business here? The distance between 5 and 9 is 4, right? So your base is that one. And what's going to be your height? We're going to use the left, so you're going to use this one, and this one. So it's going to be 4 times 23 plus, what's the distance between 9 and 12? That's going to be 3. That's your base. The height is going to be 29. Okay, plus, and then what do you have here? The distance between 12 and 17 is what? 5. Okay, and the height is going to be 36. Okay, because you are doing the left estimation. Okay, if it was the right, it would be the other 3. Okay, so you have that situation. You can leave it like that, right? But since I'm crazy, I just added all. So you have 359 divided by 12. Okay, so that's your estimation of f average. Cool. So a lot of students, this is a typical question in an AP test. They forget the 1 over 12, you know, because they are distracted and they don't see this. Okay, so please be careful with that. Okay, let's go over the next question over here, so you can see that it's not that bad as well. They tell you that in this example, a study suggests that between the hours of 1 p.m. and 4 p.m. on a normal weekday, the speed of the traffic on a certain freeway exit is modeled by the formula, and they give you the formula: S of t is equal to 2t cubed minus 21t squared plus 60t plus 20, where S of t is measured in kilometers per hour and t is the number of hours past noon. Okay, so please note that your 0 is this time past noon. Okay, so the number of hours past noon, meaning this is going to be 1 and this is going to be 4. Great. Okay, because it's PM and PM. Compute the average speed of traffic between the hours 1 p.m. and 4 p.m. Use your calculator and give. I don't think that we need the calculator. Okay, so but we can use it. Okay, so what do you have here? Whatever the function, in this case you call it S average, right? Because that's the function that we have. What's going to be that? That's going to be 1 divided by what? 4 minus 1, integral from 1 to 4. Why? Because that's the times that we care about the situation. You're like, I don't need the calculator because that's a polynomial, right? So it's pretty easy to integrate. So let's practice. Okay, so plus 60t, okay, plus 20, okay, integrate dt. Okay, so you have the situation. Okay, so you can integrate that. If you want to integrate this, you have that it's 1 over 3. Okay, and then you integrate the situation, which is going to be what? 2 to the power of t to the power of 4, so t power 4, and then you have that it's going to be half, minus, and then you have 21 t power 3 divided by 3, plus 60 t squared divided by 2, that you can see that you can reduce, and then t from 1 to 4. Okay, so then you plug the 4, okay, and you can see that the numbers are humongous, so I just plug it in my calculator, and I got that. Okay, this one, okay, it was 393 divided by 2, okay, multiplied times the magical 1/3 that I have here, then we reduce, so you have 131 divided by 2, okay, and this is kilometers, okay, per hour. Okay, do you see it? Good. Okay, so let's move on to the next example. For this example, you need to find the average of the function on the given interval without integrating. Hint, graph and use geometry. Okay, so what are we going to do? Here, they give you a linear function 3 minus x if your x is between -1 and 3. Okay, so if it's -1, you know that it's -1, and then 3, 1, 2, 3. Okay, so what do you have here? It seems that here we have a linear equation. If you plug the 3, you have that this is 0. What else? Also, you can say see that an intersect here is also 3. Okay, so boom. Okay, so you have that. Okay, if you plug -1, what do you have? That it's 4. Okay, so you have something like this. So let's draw that piece of the function. Okay, so it's from here to here, right? It's from here to here. That's that piece. Cool. Now this part. Okay, so they tell you that you have that part. Okay, so for the second part that we have another linear function, 2x minus 6 from 3 to 6. Okay, 3, 4, 5, 6. Okay, so 6 is there. If I plug 6 here, what do you have? 6 times 2 is 12 minus 6, that's 6. So 1, 2, 3, 4, 5, 6. So somewhere around this area. Do you agree with that? And then I plug the 3 here, and I have that 3 is 0. Do you see it? So something, okay, that looks like this. Yes? Okay. So what are we going to do? They are telling you the average value. So what are they asking here? They are asking for f average. Okay, f average, you know that it's 1 over what? 6 minus 1, so plus 1, integral from what? From -1 to 6 f of x dx. And of course you can compute that, right? But you need to split again the integral, so be very careful. If you do, you need to split the integrals. Okay, I'm going to split them here so you can see that it's very beautiful. 1 over 7, and then I would have from -1 to what? 3. Okay, f of x dx. Okay, plus 3 to 6 f of x dx. Why? Because you can see that from -1 to 3, let's do colors here. Okay, so let me get some colors here so you can see it. Okay, you're going to have this area, right? From here, okay, all of this, right? This is going to be green, right? But if we look at the other part, okay, so it's going to be from 3 to what? 6. Okay, so it's going to be this beautiful area that we have over here. Okay, so you see it, right? So please note that they are different, right? So this is going to be this part. So what do you have here? Well, the triangles are not the same. This triangle, what's the business with that triangle? Is going to be 1/2. The base is going to be 1, 2, 3, 4. Okay, so 4. And the height, what's going to be the height? 1, 2, 3, 4. Do you agree with that? That's the first triangle. Okay, green. Okay, so that's green. Now, what is yellow triangle? Yellow triangle is going to be what? What's going to be that? 1/2, because of the formula of the triangle. 1, 2, 3. Height, what's the height there? The height is going to be 6. Okay, so you can see that they are different triangles. You can see that visually why we need to split it as well as figures or integrals. Okay, so what do you have here? You have that this is going to be 1/7, right? And then this is going to be, what's going to be that? So that's going to be 8, right? And this is going to be what? 9, okay? So you have that it's 1/7 times 17, and I don't know why I put this in one step. It's 17/7. Beautiful number, so unit square. So you can see now visually how the F average also works. It always works. Isn't that nice? So I hope that you find this video helpful. Remember, if you have any questions, write them in the comments, and I'll see you later. Bye!